Namaskar, my dear friends. Let us talk about PIC microcontroller. We are going to talk about PIC16F 18346. Similar to that, we have 18446. So there are two series. One is 18346 and one is 18446. What we will do is we will try to understand how quickly we can design the circuit. And there are two devices we are going to take. One is PIC16F 18346 and another one is PIC16F 18446. And as you can see, we have a PDIP package. So what I will do is I'll open the circuit, and as you can see, we have complete circuit here. Let me just open. Yes, so as you can see, we have the complete circuit. This is the part number for the microcontroller, which is PIC16F18446. Otherwise, you can also utilize PIC16F18346 because both the part numbers are pin to pin compatible. However, as you can see, we have PIC3 programming connector. So it requires only two pins. One is ICSP data and one is ICSP clock pin. So this clock pin and data pin, after programming, they will be utilized as IO pins. That's the reason we are going to make most uses of them. Okay. And we have the MCLR pin, which is a reset pin. Okay. Now let us quickly go through what are the different parts that is there. So we have a reset here, we have one potentiometer connected here as an ADC. Then we have two push buttons, one is this, one is this. We have two deep switches. Then we have three LEDs connected like this and two more LEDs for high current application. They are connected like this. Okay. Then we have pin mapped properly with SPI interface and I2C interface, as well as we have several IO ports. Okay. Then we can see down we have USB power availability as well. For USB mini connector is there, that this is the part number for this from Worth Electronics. We are not using USB like plus minus like USB P and USB N, that is D plus D minus. We are not utilizing that. Just to power up the system, we are using this particular USB connector. Okay. Then we have like on board one temperature sensors. So one temperature sensor I have put it, and it is going to RF4 as a analog to digital input. Then we need power supplies. So as you can see, we have power indicator, then we have power connector, and we have power jacks, and we have power selection pins. Then we have this. This is one of the best LDO that is there from like any input to 3.3 volt output. And last one is we have two one SPI interface EEPROM is there. Then one alarm buzzer is there, that is audio buzzer. One more EEPROM is there using I2C like I2C interface. Then we have one temperature sensors using like NTC. So NTC part number is this. As you can see, we have NTC. And then we have one ambient sensor. So ambient sensor also can be used for this particular purpose. Okay. So this is all that we are going to see about this. So this was all about like continuously seeing the particular circuit that you have seen. So let me open the design document that we have. So this is the design document that is there for both the parts, 18346 and 18446. And you can have dash IP or dash EP. EP for extended temperature range, and this is for industrial temperature range. Okay. So as you can see, we have proper like table of contents, that is pin compatible parts. We have microcontroller schematic, evaluation boards. Then we have like schematic design. All the parts have been put one by one. So if you wish to have this design document, you can have directly, so that you can have an understanding of each and every part separately, like reset, ADC, potentiometer and all these things. Okay. So let us start one by one. So very quickly you can see we have two parts, that is 18446 in PDIP package. Okay. PDIP 20 package, and this is also same part with SOIC package. Okay. So these are the things that is there. Similar to that, we have 18346 and 18346 for both the parts. Okay. Now coming back to pin compatibility. So both parts are pin compatible to each other. Now talking about pin configuration. So you can see 18346 is this and 18446 is this one. Okay. We have the availability of like evaluation boards from Microchip microcontrollers. So Microchip technology has actually produced the evaluation board as well. So it looks like this, and we have several functionalities in this. We have already been like programming using the same board that is there using PIC16F 1619. So this is the board that I have purchased for you guys to do, but almost all the things are same as 18346 and 18446. So what happens is this 18446 and 18346 have little bit advanced functionalities and better qualities ADCs. All right. And this is the bottom view of the evaluation board, and as you can see, I have shown you the picture of the board that we have been using for programming. So this is the board that is being used for programming, Curiosity Microchip board, right? Now let us proceed next. So let us come to the schematic design part. So as we had seen one by one, so this is the like microcontroller programming part. So what you have to do in programming part is you have to take 2.5 mm pitch connector of 6 pin. This is how you have to do. Then first pin will be MCLR pin, that is your reset pin, then power pin, then we have ground pin, and we have data pin, we have clock pin, and the last pin is actually earlier it was used for PGM function, okay, but now it is left open. So there are three things that were there earlier: PGC, PGD, and PGM. Okay, so PGM is not being used these days. All right. Now let us talk about the microcontroller IOs. So microcontroller IOs I have named as it is. I am not renamed it. Okay, and these are the some communication interfaces and ADC interfaces that is there like this. Okay. Coming back to next part, we have reset and ADC potentiometer. So reset button is this. Once you press this, the what will happen? This will get grounded. So this is how MCLR pin will get grounded, and MCU reset will happen. So if there is a problem or functional, like functionality issue in the microcontroller and you wish to reset, you just have to press this particular button and it will be resetted. Similar to that, we have one ADC potentiometer. So this potentiometer knob, once you start rotating, the voltage level will change, and this is how ADC will help you to read that particular voltage level, and this is how you can test a very nice, like ADC functionality using this particular potentiometer. Then we have ADC user LEDs. So user LEDs, this is the like directly it is being connected. So what is happening is whenever my user IO goes high, this particular MOSFET will switch on, and this is how LED will start glowing. And once it becomes like like low, then what will happen? Low, then this MOSFET will be switched off, and this is how it will be off. So this is how it will work. Similar to that, other MOSFET will also do the same thing with this LED D7. Now, if you wish to directly drive the LEDs, you can drive LEDs through user IOs. So user IOs are connected through user LED 1, 2, 3, and this is how these three LEDs will be working. So what I have put is I have put the part number for green LED, red LED, and yellow LED. So this is how you will be having three different colors LED for different purposes. If you wish to have like several LEDs, you can similar to that you can connect with resistor and an LED. So you have to keep on adding one by one. Okay, coming back to other part, we have push button. So push button, how to connect push button is very simply, like I have explained you several times. So you can see that this is the power that is connected, and my user PB0 is connected to my microcontroller IO. Now once this is like going to microcontroller, this is seeing high. So whenever you press this particular switch, what will happen is this will pull it to ground, and this is how my user IO will read as low. So whenever push button is will be pressed, this will read low. Similar to that, USB user PB0 also will read low whenever this PB push button will be pressed. Okay. A very like a marvelous functionality is there by using deep switches. So if you wish to configure one of the IO as 0 or 1, you can utilize a deep switch which will be open in this side and which will be closed in this left side. So once it is closed, what will happen is this will be reading as 3.3 volt in the IO, and this is how it will be high. And once it is like a right side, then it will be low. So it is how open and close. Okay. So if you wish to have complete bill of material for this particular schematic design, you can always like reach out to us, and we will give you exact design so that you can directly send this particular design for your like assembly and fabrication. Coming back to next part, so what I have done is USB mini B power connector is there. So this can be utilized to power up your board through your laptop. Okay, so I am just using B bus with one filtering ferrite bead, and this B bus will be utilized to power up the system. Anyway, I have put D plus and D minus as a like a separate functionality with TVS diode or ESD diodes, but this USB N and USB P I am not utilizing right now. If you wish to, you can refer my previous video. In that you can connect these two to your USB to UART bridge. Okay, UART bridge. So this USB to UART bridge will be able to help you out to send your data from the microcontroller to your PC very easily. Coming back to other parts, we have temperature sensor. This is very nice temperature sensor that is being used like very popularly. So it can be used to sense the temperature, and this is going to your ADC pin of your microcontroller. What I'll do is I will tell you how to configure all these particular pins in a like programming using MPLAB MPLAB X. So what I'll do is MPLAB X I will open in our next video, and in that I will configure each of these pins for these functionalities properly, so that you can have an understanding of how to start writing your program as well. Now, the most important part is coming up as power supply. So power supply connector I have given, which is like either you can give it from 5 volt to 12 volt DC input. So DC power supply you can connect at this particular connector. Otherwise, you can connect a adapter also. So adapter jack is given. Generally, you will get several power supplies adapter, that is 6 volt. Let us say like a 6 volt 2 ampere rating, or 12 volt 2 ampere rating, or like a 1 ampere rating, something like that you can connect. So up to 12 volt I suggest you to connect here, and this will go to like a V in A, and this V in A will make it happen. Like I will just tell you how it is going to happen. Yeah, this V in A, you have to just sort these two pins so that VCC will appear, and this VCC will make sure to come as 3.3 volts. So this is a linear regulator that is being used to convert my input voltage to your output voltage. And this will be supplied to power up your microcontroller, your all other functionalities and systems and everything. Okay. And this particular LED is actually going to indicate whether the power is there in the system or not, and this VDD has been renamed as a like net name. If you wish to, you can continue with 3v3 itself by removing this like resistor and just sort it directly. Okay, so that's not a problem. Now, going to next, we have several other parameters, like we have EEPROM. So EEPROM, this is 256 kilobits EEPROM using SPI interface. So you can see very nicely it has been, like protection has been disabled. So directly it is always, like made writable, so that you can, like always pull it up. If you want to control this, you can connect it through an IO. And once you disable, you want to disable, you pull it down. So it will be disabled. You won't be able to write it. Okay. So we have slave select pin, and then we have SPI SDI data input and SDO data output, and we have SPI clock pin. And this is the power supply that is there for your functionality, which is VCC, and hold is disabled as well. Okay. Very nice functionality that is needed, like in circuits, is basically audio buzzer. So audio buzzer, what I have done is you can utilize one audio buzzer, that is CST-931AP, where this is the freewheeling diode that is being used here. And now here it will be used as PWM, and this PWM will be making sure that this audio buzzer starts giving you sound beep beep beep. Okay. If you wish to, you can utilize some other MOSFET as well here. So if you wish to, you can utilize MOSFET as well instead of using the transistor. Coming back to next part, we have one more EEPROM that is there using I2C interface. So I2C interface, what happens is, this is very simple interface I2C. So if you wish to, either you can utilize SPI interface EEPROM or I2C EEPROM by removing one of the resistors from the board. Now one more interface that we have given is ambient sensor. So as soon as ambient light appears here, this particular sensor starts giving you a voltage, and this voltage level will be read out through ambient sensor ADC pin. So this is how ADC will be reading the output and giving you an opinion like what is the daylight or what is the lighting situation in the environment. Similar to that, we have one more temperature sensor that is being used as NTC, that is negative temperature coefficient sensor. So this is the part number that is being used, and what happens is at 25 degree centigrade, the value of that is 10 kilo ohm. So actually it will be seen as 10 kilo ohm here, and I have used one more 10 kilo ohm. So the voltage level at this will be VDD by 2. So VDD by 2 is nothing but 1.65 volt. Why? Because this is 3.3 volt. So 3.3 by 2, that is 1.65 volt. This 1.65 volt will be buffered, and then it will be going to go to the temperature sensors to it is not, it is going to actually go to your ADC, and this is how it will be reading the analog to digital value. So if you wish to amplify or something like that, I have given a provision for giving an amplification. So these two resistors you can vary, and you can have an amplification also. But anyway, amplification is not needed right now. It will be just fine by utilizing as it is. So alright guys, this was all about this particular circuit, and if you do have any questions regarding this particular circuit, how to draw this or how to complete this, I have made several videos using ORCAD. So you can see this is the ORCAD background that is there. So I am not able to show it properly. Let me just make it little smaller. Yes, so I have made it a little smaller, and as you can see, this is the window that is there, page number 1, page number 2, and page number 3. So complete, drawing method and all, everything I have already made videos, how to start drawing, how to add a library to your circuit design, and how to start a particular program or how to start a particular project. That also I have shown it to you. So if you wish to continue, or if you wish to learn more, you can always put down your questions in the comment box, and we shall be able to answer you out. So alright, thank you for now.